AI server accelerator landscape, a comprehensive breakdown of the competitive battle between NVIDIA, AMD, Intel, and Qualcomm, four tech giants racing to power the next generation of artificial intelligence. The AI server accelerator market is experiencing unprecedented growth, driven by the explosive demand for large language models, multimodal AI, and generative AI applications. As data centers scramble to meet these computational demands, the choice of accelerator technology has become one of the most critical decisions for enterprises and cloud providers alike. Let's start with the market context. We're seeing rapid growth in both training and inference workloads, with particular emphasis on memory bandwidth, computational precision formats like FP8 and INT4, and overall power efficiency. The key evaluation metrics have expanded beyond raw flops to include memory capacity, interconnect performance, and total cost of ownership. In the current landscape, we have four major players with distinct strategies. NVIDIA continues to dominate with its comprehensive rack-scale systems and mature software ecosystem. AMD is leveraging its CPU-GPU integration expertise to create full AI platform solutions. Intel is pushing an open infrastructure approach with its Gaudi 3 accelerators, while Qualcomm is entering the market with a focused inference efficiency strategy. Let's begin with NVIDIA, the current market leader. Their H200 Tensor Core GPU features approximately 141 gigabytes of HBM3E memory, specifically optimized for inference workloads. But the real story is their Blackwell architecture, offering up to 3.4 times higher throughput per GPU on certain models compared to the H200. NVIDIA's rack-scale systems are engineering marvels. The NVL72 format packs 72 GPUs with 36 CPUs, creating massive computational density with sophisticated NVLink interconnects. Their strengths are undeniable: the deepest software ecosystem with CUDA and TensorRT, broad hyperscale support, and proven performance at scale. Moving to AMD, they're taking a different approach by leveraging their CPU and GPU expertise together. The MI300, MI350, and upcoming MI400 series are designed to work seamlessly with EPYC CPUs in a host accelerator combination. Their MI350X is rumored to feature around 288 gigabytes of HBM3E memory per chip. In June 2025, AMD unveiled their Helios rack-scale AI server platform with 72 MI400 series chips, demonstrating their commitment to competing at the highest level. AMD's strengths include open networking alternatives to proprietary interconnects, strong CPU-GPU integration, and core count efficiency. Intel's is taking the open infrastructure route with their Gaudi 3 accelerators, which are shipping now and claiming 70% better price performance than NVIDIA's H100 on Llama 3 80B models. Their upcoming Crescent Island GPUs are specifically targeting inference workloads in air-cooled data centers. Intel's software ecosystem leverages their broad server OEM relationships and open software stack with one API. While they face challenges in market share and software maturity compared to NVIDIA, their value proposition around cost-efficient inference and flexible infrastructure is compelling for certain use cases. Now let's look at the newest entrant, Qualcomm. Their AI200 and AI250 accelerators represent a focused approach on inference efficiency. The AI200 supports up to 768 gigabytes of LPDDR5 memory per card, while the AI250 introduces a near-memory computing architecture promising 10 times the memory bandwidth of competing solutions. With AI200 scheduled for 2026 and AI250 for 2027, Qualcomm is betting on high memory capacity and power efficiency as their key differentiators. Their focus on total cost of ownership for inference workloads could be disruptive, though they face the challenge of being new to the data center AI market. When we compare these solutions side by side, several patterns emerge. NVIDIA leads in raw performance and ecosystem maturity. AMD offers strong integration and open alternatives. Intel focuses on value and open infrastructure, while Qualcomm is betting on memory efficiency for inference workloads. The critical evaluation dimensions extend beyond simple specifications. Memory capacity and bandwidth are vital for large models and context windows. Compute precision support for formats like int4 and FP8 enable efficiency optimizations. Interconnect performance determines scaling capability, while software ecosystem maturity affects deployment velocity. Perhaps most importantly, efficiency and total cost of ownership are becoming primary decision factors, especially for inference workloads run at scale. This is where challengers like Intel and Qualcomm see their opportunity to differentiate from NVIDIA's premium-priced solutions. For enterprises and data center operators, the strategic implications are significant. Hyperscalers must evaluate beyond raw throughput to consider TCO, power and thermal requirements, memory footprint for large models, and software ecosystem maturity. For inference-heavy deployments, think large language model APIs, chatbots, and real-time ML applications, metrics like cost per token and power per token become crucial differentiators. This is creating opportunities for specialized inference accelerators to gain traction. The expansion of vendor choices brings both opportunity and complexity. While more options means better pricing and negotiation leverage, it also increases the challenge of ecosystem support and integration testing. Platform lock-in risk and software dependencies remain important long-term considerations. So, what does this mean for your organization? If you need Tier 1 training and inference performance today, NVIDIA remains the default choice. For large inference deployments where cost efficiency matters, the challengers deserve serious evaluation. AMD offers strong integration, Intel provides open infrastructure value, and Qualcomm promises memory efficiency, though with future availability. The key is matching your specific workload requirements to the right accelerator profile. Large language models and multimodal AI need substantial memory footprint and bandwidth. Smaller inference tasks may prioritize pure efficiency. Hybrid workloads might benefit from balanced architectures. Looking ahead, the 2026 and 2027 timeframe promises significant innovation. AMD's MI400 series, Qualcomm's AI250, and Intel's Crescent Island GPUs will bring new capabilities to market. Organizations should monitor these roadmaps closely, as timing may influence deployment schedules and technology refresh cycles. In summary, the AI server accelerator market is rapidly diversifying beyond the NVIDIA-dominated landscape of recent years. While NVIDIA maintains leadership in performance and ecosystem, credible challengers are emerging with compelling alternatives, particularly for specific use cases like cost-optimized inference. The most successful organizations will be those that make strategic decisions based on total cost of ownership, workload-specific requirements, and ecosystem considerations, not just peak performance specifications. The era of one-size-fits-all AI acceleration is ending, replaced by a more nuanced landscape of specialized solutions. As we look toward 2026 and beyond, the competition in AI accelerators will only intensify. This is great news for enterprises and developers, driving innovation, improving efficiency, and expanding the possibilities of what we can build with artificial intelligence. Thank you for joining this exploration of the AI server accelerator landscape. The race to power the future of AI is underway, and the winners will be those who make strategic choices aligned with their specific needs and future roadmap.